All right, in this video, I'm going to pick up where I left off in last video. I did all the odd problems in last video. I'm going to do the even problems in this video, so it's the sign problems. So problem number 2, we need to be careful about. I still want to identify the amplitude and the period. Amplitude is pretty straightforward. It's a 1. Period's a little bit not as straightforward. Now, it might help you if you can't quite figure out what the coefficient of x is, because by the way, it's not 2. If you can't quite figure it out, it might help you to rewrite this as sine of 1/2 x, and that might give you the hint, maybe. In this case, we're going to take 2 pi and divide by 1/2. Now, if you take 2 and divide by 1/2, you don't get 1, you don't get 2, you get 4 pi. All right, so just be aware of those fractions. They're kind of messed up. If you want to think about it in terms of this work right here, to get rid of this denominator of 1/2, you would multiply it by 2, which means you'd have to multiply the numerator times 2 as well, hence the 4 pi. So for the period here, I'm going to go ahead and label 4 pi. Half of that would be 2 pi, half of that is just pi, and then pi times 3 would be 3 pi. I'm going to do another half somewhere, and that's just not right. So let's go ahead and label the y-axis for my amplitude. Maximum is 1, minimum is -1. And sine, the sine curve generally, in this case, is going to start at 0. And there's no reflections or anything like that. So we're going to go up to +1, back down to 0, to -1, back to 0. And our curve looks like this. So one of the things to pay attention to with the period here, this period changes b value of 1/2. Basically what you're seeing is half of a normal curve in the regular amount of time that you would, in the regular period. Remember, sine normally has a period of 2 pi, and if we look at just 0 to 2 pi, you're only seeing half of the curve, hence the 1/2 x. It's one way to think about it. Lots of different ways to think about these. Okay, so number 2 is done. I'm going to go ahead and slide down to number 3. No, number 4, I already did number 3. All right, let's see what all the parts that we have here. We have a negative. We have a 2. We have a 1/4 sitting in front of x. So we got a whole bunch of stuff going on here. Okay, the negative is a reflection over the x-axis. The 2 is going to give us an amplitude of 2. And period here, I'm going to take 2 pi divided by 1/4. So if I multiply by 4, I'm going to get a period of 8 pi. All right. So what you would normally see from 0 to 2 pi is actually only going to be 1/4 of the graph. So clearly in this case, your period is a lot larger than it was normally. All right, so let's go ahead and label 8 pi, chop that in half, 4 pi, half of that's 2 pi, triple that up, that's going to get me 6 pi. I'm going to go ahead and label the y-axis. Maximum is 2, minimum is, I don't know why I just wrote 3. Minimum is -2. All right, so I'm going to start at 0. But I want to pay attention to the fact that I have a reflection here. So instead of going from 0 and increasing up to my maximum, I'm going to reflect over the x-axis and I'm going to decrease down to my minimum, bounce back up to the midline, up to the maximum here, and down to the midline. Draw the pretty continuous curve. Again, it's a smooth continuous curve. Just like cosine, so just be aware of that. Problem number 4 is done. I'm going to go ahead and slide down to number 6 here. Let's see what fun we have. Apparently all the fractions were with sine here. We've got a 4 here, and we've got x over 3 here. If it helps, all right, feel free to take a second and rewrite this as 4 sine of 1/3 x. Maybe that'll help you. If it does, do it. There's no penalties to there. I'm not going to look at it and say, oh, I can't believe you had to do that. No, do what you need to. So we've got an amplitude of 4. We have a period here of, well, whatever 2 pi divided by 1/3 is. So that's going to be 6 pi. All right, so I'm going to go ahead and put 6 pi here. Half of that would be 3 pi. Half of that would be 3 pi over 2. Triple that up, we're going to get 9 pi over 2. Radians are almost always, for my usage, written as fractions, so please get used to writing them as fractions, even if you need to grab a calculator to maybe help you out with dealing with the fractions there, or the division. I'm going to go ahead and label the y-axis here. There's my 4. Down here would be -4. All right, so let's put a curve here. I'll go green. Sure, why not? Sine starts at 0. Normal sine curve is going to increase up to the maximum, in this case 4, drop down to the midline, decrease to the negative, to the minimum, -4, and pop back up to the midline. So that amplitude stretches the graph further away from the x-axis. And in this case, the period change has also stretched the graph further away from the y-axis, because somewhere right around here, maybe, I don't know, here-ish, would be 2 pi. So what you would normally see from here to here as a full cycle has been stretched so that you're only here seeing 1/3 of the cycle between 0 and 2 pi. And so you have to go all the way to 6 pi to see the full cycle, or the full period of the curve. All right, I'm going to go ahead and stop the video here. If you've got any questions or concerns, please let me know what I can do to help.